March 21st, 2025. President Trump steps to the podium and says three words that made defense analysts go silent. The F-47. A fighter jet nobody knew existed. Except it's been flying in secret since 2019, 6 years hidden from the world. While China paraded their prototypes for cameras, America was testing something so advanced, so classified, that even talking about it could end careers. The NGAD program isn't just building a fighter, it's weaponizing the future. And what leaked out will show you why every adversary is already too late. The NGAD story starts where most classified programs do, in absolute secrecy. But unlike traditional fighter development that takes decades, something unprecedented happened in 2019. A full-scale demonstrator took flight, not a concept, not a prototype, a complete 6th-generation aircraft. DARPA's Aerospace Innovation Initiative had been running under the radar since 2014. Boeing and Lockheed Martin each built their own X-plane demonstrators, testing radical technologies that would make 5th-generation jets look primitive. Boeing's demonstrator reportedly achieved extensive flight testing before most defense analysts even knew it existed. The Air Force calls this Digital Century Series development, designing, testing, and producing advanced aircraft faster than ever thought possible. Traditional fighters like the F-22 took over 20 years from concept to operational service. NGAD's demonstrator went from drawing board to flight test in roughly 5 years. Did you know? The NGAD demonstrator program cost a fraction of what the F-35 development required, yet achieved technological breakthroughs that leapfrog an entire generation of combat aircraft. This speed wasn't just impressive. It was strategic. While competitors invested decades in 5th-gen technology, America quietly vaulted into 6th-gen dominance. By 2024, Air Force Secretary Frank Kendall initiated what he called a strategic pause, not because of problems, but to ensure NGAD would integrate seamlessly with emerging autonomous combat systems. The program wasn't slowing down. It was evolving in real time, adapting to a battlefield that now included AI wingmen and networked warfare. When Boeing won the engineering and manufacturing development contract in March 2025, the deal was valued at over $20 billion. But that's just the beginning. The full program budget from 2025 to 2029 totals $28.5 billion, with production ramping up around 2030. The first operational aircraft is expected to take flight in 2028, just 3 years away. President Trump's words were carefully chosen. State-of-the-art stealth technologies making it virtually unseeable. That's not marketing hype. The F-47 represents a quantum leap beyond anything currently flying. 5th-generation stealth, like the F-22 and F-35, focused on radar cross-section reduction through shaping and materials. The NGAD takes this several dimensions further. We're talking about multispectral stealth designed to defeat radar, infrared, visual, and electronic detection simultaneously. Leaked design concepts suggest a possible tailless flying wing configuration. This isn't just about aerodynamics. It eliminates radar return angles that even the F-22 can't fully conceal. Every surface, every edge is optimized not just for radar absorption, but for countering next-generation detection systems that China and Russia are actively developing to challenge American stealth. The materials alone represent a generational shift. Advanced metamaterials and adaptive camouflage technologies could allow the F-47 to alter its signature based on the threat environment. Imagine an aircraft that reconfigures its electromagnetic signature in real time, becoming invisible to one radar frequency while simultaneously jamming another. But here's where it gets truly revolutionary. The F-47 isn't designed to hide from everything. It's designed to control what the enemy sees. Active stealth technologies may allow it to project false radar signatures, making one aircraft appear as multiple targets or disguising its true position and speed. Infrared suppression also reaches new extremes. The NGAD's adaptive engine technology, developed under the Next Generation Adaptive Propulsion Program, doesn't just reduce heat signature, it modulates exhaust temperature and dispersion patterns, making infrared detection extremely difficult even at close range. Did you know? The F-47's stealth capabilities extend into the cyber domain. Its advanced electronic warfare suite can reportedly create ghost fleets in enemy detection systems while simultaneously mapping and probing adversary networks. This isn't just stealth, it's battlefield deception at machine speed. At the heart of the F-47 beats something no fighter has ever possessed: a true adaptive cycle engine. This isn't an incremental improvement, it's a fundamental reimagining of jet propulsion. Traditional turbofan engines operate in a fixed configuration, optimized for either fuel efficiency or raw power, never both. The NGAD's adaptive engine, developed through years of NGAD, Next Generation Adaptive Propulsion research, changes everything. It physically reconfigures aspects of its internal airflow during flight. At subsonic cruise, the engine operates in a high bypass mode, conserving fuel much like a commercial airliner. When combat demands arise, the engine shifts. Variable geometry components redirect airflow, enabling high-thrust output capable of sustained supersonic speeds, potentially even without afterburner. This super cruise on-demand capability means the F-47 could patrol vast distances efficiently, then unleash speed and power when threats emerge, all without the extreme fuel consumption that limits current fighters. Some projections suggest a combat radius exceeding 1,500 miles with a full weapons load. The performance figures reportedly associated with the NGAD platform are staggering. Maximum speeds may exceed Mach 2.2, but more notably, the engine is expected to sustain high-performance maneuvers at altitudes and speeds where current fighters face energy and fuel limits. The thrust-to-weight ratio is said to significantly outperform existing platforms. Thermal management is also redefined. The adaptive engine incorporates advanced cooling technologies, not just to prevent overheating, but to repurpose waste heat. This recovered energy could potentially power directed energy weapons or high-demand electronic warfare systems. Every joule becomes combat effective. Maintenance requirements are expected to drop dramatically. With fewer moving parts in critical sections and modular design elements, reliability improves. The engine is reportedly designed for up to 8,000-hour service intervals, roughly double the lifespan of current military turbofans. This isn't just about power, it's about availability, sustainability, and reduced life cycle costs. Before we reveal the intelligent system that make this jet unstoppable, hit subscribe and ring that bell. We're covering military tech most channels can't touch. Drop a comment. Will NGAD dominate for 30 years? Now, let's talk about the brain inside this beast. The F-47 isn't just flown by a pilot, it's partnered with artificial intelligence that processes battlefield data at speeds human cognition cannot match. This is where 6th-generation fighters are said to separate themselves from everything that came before. The AI systems on board aren't simple autopilots or targeting assistants. They function as combat decision engines capable of ingesting inputs from dozens of sensors simultaneously, identifying threats, calculating response options, and recommending or executing maneuvers far faster than a human reflex loop would allow. Sensor fusion reaches unprecedented levels. The F-47 pulls data from its own radar, infrared search and track, electronic warfare receivers, and data links with friendly aircraft, satellites, and ground stations. The AI synthesizes this stream of information into a single, coherent tactical picture, updated at very high rates to support near real-time decisions. Where the system becomes especially potent is in learning and adaptation. Machine learning algorithms can study adversary tactics, identify patterns, and forecast likely actions. If an opponent routinely uses a particular maneuver under pressure, the AI can recognize that tendency and present counter-options before the maneuver is complete. The pilot's role shifts toward tactical command rather than pure stick and rudder flying. The AI handles many moment-to-moment tasks, flight management, weapons coordination, and defensive responses, while the human supervises strategic choices, which targets to prioritize, when to engage, and when to break contact. That division of labor is intended to multiply combat effectiveness. Collaborative combat aircraft concepts extend this further. The F-47 is designed to coordinate with autonomous drone wingmen, each carrying weapons, sensors, or EW payloads. The AI orchestrates those assets, positioning drones for optimal effect while preserving the survivability of the crewed fighter. Some descriptions claim the NGAD's AI can rapidly simulate large numbers of engagement outcomes, effectively wargaming many tactical options in milliseconds or faster, allowing it to evaluate and recommend courses of action that would be impractical for a human to compute in the same time frame. Cyber and electronic attack capabilities are integrated into the overall combat system. The platform's EW and cyber toolset is intended to identify network vulnerabilities, inject deceptive data into adversary sensors, and help coordinate multi-domain effects that combine physical and information domain actions. These capabilities align with modern concepts of integrated information age warfare, though detailed public confirmation of specific techniques remains limited. When the Air Force first conceived NGAD, collaborative combat aircraft were not a central part of the concept. As autonomous technology matured faster than planners expected, however, leaders saw how unmanned wingmen could multiply an F-47's lethality and flexibility. CCAS are not simple off-the-shelf drones. They are intended to be attritable, autonomous combat assets, capable of complex air combat maneuvers, yet designed to be affordable enough that losing one does not cripple a mission. Each CCA can be configured with mission-specific payloads, air-to-air weapons, strike munitions, jamming pods, or specialized sensors. The F-47 pilot commands these wingmen through highly intuitive interfaces. Work is underway on advanced controls. Voice commands and gesture interfaces are in active development. More experimental ideas such as brain-computer links are being researched but remain developmental. The objective is clear: make directing multiple autonomous teammates as natural as flying the host aircraft. Tactical options for a crewed fighter commanding CCAs become far broader. Need to saturate enemy defenses. Send CCAs ahead, carrying decoys and anti-radiation assets. Outnumbered. Use drones to set ambushes while the manned fighter gains the advantage. Need persistent ISR. Station CCAS at standoff ranges, while the crewed platform maintains survivability. The cost calculus shifts. A crewed 6th-gen fighter is a high-value asset. CCAs are designed to be much less expensive per unit, enabling commanders to field mixed packages that deliver force-multiplied effects at lower marginal cost and reduced risk to pilots. Attrition of drones is operationally painful, but less strategically damaging than the loss of a crewed aircraft. Recovery and reuse are important design goals. Unlike expendable missiles, CCAs are intended to return, be serviced, retasked with different payloads, and fly again, turning each airframe into a multi-mission asset rather than a one-shot expendable. Adversaries are accelerating their own autonomous and AI programs in response, but building safe, reliable, combat-capable autonomous fighters at scale is technically and operationally challenging. Fielding comparable, fully integrated CCA fleets requires advances across autonomy, communication security, and logistics, areas where timelines vary and public information is limited. Still watching. That means you actually get it. Hit that like button if this is blowing your mind. It tells YouTube to push this to more people. And if you haven't subscribed yet, what are you waiting for? We've got 2 more game-changing chapters left. Let's finish strong. The F-47's weapons bay represents the next evolution of integrated firepower. Forget traditional hardpoints and pylons. This is about internal carriage, maintaining stealth while packing devastating punch. Next-generation air-to-air missiles extend kill ranges beyond anything currently deployed. We're talking about weapons that can reach out 200-plus miles, traveling at hypersonic speeds and maneuvering with G-forces that would destroy older missiles. Enemy fighters won't just be outranged, they'll be fighting an invisible opponent that kills from distances their radars can't even detect. Directed energy weapons finally become practical. The F-47's adaptive engine generates enough electrical power to run high-energy lasers and microwave weapons. These aren't science fiction, they're operational. A laser that can burn through incoming missiles or disable enemy sensors at light speed, with unlimited ammunition as long as the engine runs. Air-to-ground capabilities scale up proportionally. Penetrating strike missions against heavily defended targets become routine. The combination of stealth, speed, and standoff weapons means the F-47 can strike targets that current fighters couldn't touch without unacceptable losses. The weapons integration goes beyond physical munitions. Cyber weapons launch from the same systems management interface as missiles. An F-47 can simultaneously fire kinetic weapons at physical targets while injecting malware into enemy command networks, all coordinated by the AI to achieve maximum disruption. Electronic warfare reaches offensive extremes. Instead of just jamming enemy radars, the F-47 can feed them false target data, creating phantom aircraft that enemy fighters waste missiles engaging. Or worse, it can make enemy aircraft appear as threats to their own side, triggering fratricide. Did you know the F-47's weapons bay is designed with modular architecture, allowing rapid reconfiguration between air superiority, strike, and electronic attack loadouts? The same airframe can shift roles between missions faster than ground crews can refuel current fighters. When China unveiled their 6th-generation fighter prototypes, Western analysts noted something crucial. They were showing concepts the US had been flying in secret for years. The gap isn't closing, it's widening. Russia's fighter programs are effectively frozen. Economic sanctions, technological isolation, and brain drain have crippled their aerospace industry. The Su-57 barely entered production, and prospects for anything beyond 5th generation are non-existent. Russia is out of this race. China represents the only serious competition, but they face insurmountable obstacles. Their engine technology lags a full generation behind American capability. Their adaptive cycle engine programs are where the US was a decade ago. Without the propulsion breakthrough, everything else suffers. Range, speed, power generation for directed energy weapons. The strategic pause in 2024 that caused some anxiety, that was America's luxury, the ability to step back, reassess, and optimize because we were already so far ahead. China doesn't have that luxury. They're sprinting just to catch where we were 5 years ago. Boeing's contract win accelerated the timeline. Production beginning around 2030 means operational F-47s could be patrolling contested airspace by 2032. By then, the US will possess hundreds of 6th-generation fighters and thousands of collaborative combat aircraft. No adversary will come close to matching this capability. Cyber weapons. While China chases yesterday's technology, America owns tomorrow's battlefield. Smash that like button and subscribe right now. We're dropping exclusive military tech breakdowns every week. Hit the bell so you never miss it. Drop a comment. What should we cover next? Stay informed, stay ahead.